Okay. Jelly beans and mints worth $2.10 per kilogram and $2.70 per kilogram, respectively, were mixed to make 500 kilograms of mixture, which sold for $2.52 per kilogram. How many kilograms of mints were used? So, I'm sorry for my lackluster writing here, but we're going to ignore it, and we're going to figure out this question. So right away, you can see we have the $2.10 for the jelly beans and the $2.70 for the mints. So it's pretty easy to say that we can do J plus M equals 500 kilograms, because that's your total in the end. So now that we know that, we can say we're looking for J right now, just because. And so we'll move the M over to the other side, so it'll be J equals 500, ignore the kilograms at the end because we don't really need that right now, minus M, because we change signs when we come over. So we have J equals 500 minus M. So now we can write out the equation. So since we have the numbers here and here, the 2.10 kilograms and the 2.7 kilograms, we'll put those into the equation. So 2.10, what do we say that is? J. 2.7J equals 2.10 I'm doing something. 2.70, sorry. I'm having an off day. So 2.10J equals 2.70M equals, and this is where when I was writing it I got a little bit confused, but I ended up figuring it out. So it was 2.52, because that's the amount of kilograms that are being sold in the bunches, multiplied by 500, which is your total. So hopefully you can see that. Let me just check. Yeah, you can kind of see the edge there. But it's the 2.10J plus 2.7M equals 2.52. It should be 2.52 times 500. So now that we have that, we can sub in our equation here right behind the J. So it becomes 2.10 multiplied by 500 minus M. I don't know why that's there. Should be plus. Yeah, that should be a plus number. Plus 2.70M equals 2.52 multiplied by 500. So that gives you your equation for that. We have the M subbed in, or well, the J subbed in, but looking for the M equation. So we can now multiply these because they're inside the bracket. So everything in the brackets will be multiplied by the number in front. So 2.10 will be multiplied by 500, which will give us 1,050, and minus, because the sign's still inside, minus 2.10M, because it carries over, because the M is literally just a 1. If you're looking at it in a simple way, the M is kind of just a 1 when it's by itself. So you're timesing 2.10 times 1. So that just comes out to 2.10 M plus 2.7 M equals, and then the other number on this side is that would be 1,260. So you have your numbers there. Now we're gonna have to rearrange. So we'll say that this is minus 2.10 plus 2.70 equals 1,260, sorry. Ooh, it hurts. Minus 1,005 or 50. I have a really hard time picturing this in my head. I'm just gonna make sure that the camera can still see it. Sorry. I just moved that over a little bit. So now that we have that, we'll put this together. This ends up being 0.6 m equals, I believe that is 210. Yes. So 210. So the 0.6 m equals 210. So now we want to self-isolate. We need to isolate the m. So to isolate the m, we need to do the same thing to both sides. So you divide everything by 0.6 in the equation. So that becomes m, and the other one becomes 350, because you're multiplying by a decimal, or dividing by a decimal. So the mints equal 350. So therefore, 350 kilograms, I'm having a really hard time writing, kilograms of mints were used. Again, sorry for my very lackluster writing, but the answer to the question would be 350. A good way to check is you have your 500 and you have your 350. If you wanted to get the amount for J, the simplest way to do it would be to put J equals 500 minus m, and we know that m is 350, so the m is just subbed in for 350. So J equals 500 minus 350, which brings J to equal 150. And there you go. So in this equation, 150 kilograms of jelly beans were used in the mixture, and 350 kilograms of mints were used. That is my lackluster explanation.